Is artificial intelligence actually getting smarter? Or are we just calling it that without any real way to measure it? 391 research papers later. And today we finally have a structured answer. The field just got its first real report card. And it says something surprising about where we actually are on the path to AGI. Welcome back. You've probably heard the debates. Is this AGI or isn't it? Are we there yet, or are we decades away? The problem is we've been asking the wrong question. Today, I'm going to show you how researchers are finally moving past that binary thinking and building a real roadmap for artificial general intelligence. We'll look at a new framework that actually measures AGI progress, a breakthrough in edge computing that brings general intelligence to your devices, and why the future of AI might not look like what anyone expected. Stay until the end, because what researchers are saying about our expectations for AI might surprise you. Here's the thing about artificial general intelligence. We've been having the same conversation for years. Is this AGI or isn't it? Every time a new model drops, the internet explodes with hot takes. But here's the problem. We've been asking the wrong question. It's not about whether something is or isn't AGI. It's about where it falls on a spectrum. Today's research introduces a framework that does exactly that. The levels of AGI proposal gives us something the field has desperately needed: a structured way to measure progress. Think about self-driving cars. We don't just ask, is this car autonomous or not? We have levels. Level 2, Level 3, Level 5. It gives us a shared language. Now, the same thing is happening for AGI. This new 5-level taxonomy: emerging, competent, expert, virtuoso, superhuman, maps out the path from where we are now to where we're going. And here's the reality check. According to this framework, our most advanced frontier models, there's Level 1, emerging AGI, better than an unskilled human, sure, but not yet competent. This matters because for years, we've been stuck in this binary trap. Is it AGI or isn't it? That's like asking if a car is autonomous or not, when in reality, there's a massive gulf between a car that can keep its lane on the highway and one that can navigate a busy city intersection. The levels of AGI framework gives us that same nuance. It ties each level to what we can actually deploy, what risks we're taking, and how humans should interact with these systems. And this isn't just theoretical. The second paper today, Edge General Intelligence, shows us what Level 1 actually looks like in practice. We're talking about a 3-tier cognitive architecture running on something as small as an NVIDIA Jetson Orin, a device you could fit in your hand, achieving 72% success on complex, long-horizon manipulation tasks with inference latency under 50 milliseconds. The system uses a subconscious layer for reactive control, a cognitive layer for deliberative planning with learned world models, and a meta-learning layer for self-adaptation. The key insight: world models. The system learns how the world works, then uses that understanding to plan its actions, reducing real-world interactions by up to 40% compared to traditional model-free reinforcement learning. Think about what that actually means. Instead of learning through millions of trial-and-error interactions in the real world, breaking things, failing repeatedly, the system builds an internal model of reality and can run thousands of simulated experiments in its own mind before taking a single physical action. It's the difference between learning to cook by burning 100 meals versus reading a recipe book first. That 40% reduction in real-world interactions isn't just an efficiency gain. It's a fundamental shift in how we think about learning in the physical world. And it's running on a device you can hold in your hand. The NVIDIA Jetson Orin is about the size of a credit card. We're talking about general intelligence operating at the edge, with latency under 50 milliseconds. That's fast enough for real-time robotics, for autonomous vehicles, for any application where you can't wait for a round trip to the cloud. But here's where it gets really interesting. The third paper today, The Artificial Scientist, takes a step back and asks a bigger question. What's the right approach to building AGI in the first place? It systematically compares logicist approaches. Think symbolic AI, rules, logic, with emergentist approaches, neural networks, learning from data, and universalist approaches like agi that aim for mathematical optimality. And its conclusion: none of them work alone. This is the convergence we're seeing across the field. The levels of AGI paper gives us the measurement framework. The Edge General Intelligence paper gives us a practical architecture that combines reactive control, deliberative planning, and meta-learning. The artificial scientist paper tells us we need hybrid approaches. These aren't competing ideas. They're pieces of the same puzzle. And here's where it gets really interesting. The levels of AGI paper explicitly ties its taxonomy to deployment considerations and risk profiles. It's not just about capability. It's about when and how we should deploy these systems. The safety features for a centralized AGI project paper provides concrete safety measures for rapid, concentrated development. The bounded alignment paper questions what we should even expect from AGI agents in the first place. This is the field maturing. We're moving from will we build AGI to how do we measure it, how do we deploy it safely, and what should we actually expect from it? So let's talk about what this actually means. First, the levels of AGI framework gives us a shared language. When someone says we have AGI, we can now ask, what level? Emerging, competent, this matters for policy, for regul.